Alright, let's go ahead and take a look at this problem where we determine if these waves are in phase or out of phase. So here we look at part A, f of x equals 3 sine of 2 pi x minus pi force, and g of x equal to 3 times the sine and 2 pi times x minus 3 force. So how are we going to determine if these are in phase? If we have matching amplitudes, as we do, we're matching a values here. We can see, for example, I'll say a sub f equals a sub g, or the a value for f and the a value for g are equal to each other. So that's good. And note that I could rewrite g of x, maybe I will here, as g of x equals 3 times the sine of 2 pi x minus 6 pi force, which would be the same then as 3 pi halves. So looking then at this f and this g, again we still see that same amplitude value or a value. You can see that we have the same b value, so we can say b sub f equals b sub g. Our horizontal stretch is the same, and we know that if the difference of our horizontal shift, negative pi, or the difference of our phase is Woo! Alright, let's take a look at this problem. So here we'll determine if phase... Alright, let's go ahead and take a look at this problem. So we are going to determine if two given waves are in phase or out of phase. And we can even say if these waves will ever or even have a potential to be in phase as well as we go through. So let's go ahead and look at the first example. Starting over again. Alright. Alright, we're going to, in this example, determine if two waves are in phase or out of phase. So let's go ahead and start with part A. So part A, we have f of x equals 3 sine of 2 pi x minus pi fourths, and g of x equals 3 times the sine of 2 pi times x minus 3 fourths. So we have different forms of our arguments here. So the first thing I might do is choose to rewrite g of x in a similar form to f of x as 3 sine of 2 pi x. 2 pi times 3 force would be 6 pi force, which could be reduced to 3 pi halves. So we have our f of x, we have our g of x. Let's go ahead and determine if these two waves are in phase. So note that we have to have some things to be true. For example, we need our a value for f and our a value for g to be equal. We need amplitudes and also trig functions which match, or a values which match and trig functions that match, not just amplitudes. We need the same positive or negative applied on our a. So here we see that 3 sine and 3 sine, these two match in f and g. Consider our k values here. We have a k equals 2 pi and a k equals 2 pi. We can see that kf equals k sub g. Awesome. And then finally we need to determine if these phase shifts, here a phase of negative pi fourths, here a phase of negative 3 pi halves, a phase of positive pi fourths or a phase of positive 3 pi halves, the way we define phase. If this is a difference equal to, or if their difference is equal to a multiple of 2 pi, we know that we will have two waves which are in phase. See here, if I look at that difference, we could consider, for example, the difference of 3 pi halves, subtract pi force. We can see that this might be equal to 6 pi force minus pi force, or 5 pi force, which is not a multiple of 2 pi. So here we see that the difference between our phases is not a multiple of 2 pi, therefore we can say that these waves are out of phase, or not in phase. So we'll answer here, just a big old no. Give ourselves a box there. You see no, those two waves are not in phase. let's go ahead and look at part B now then. So part B, we have f(x) equals the cosine of x minus pi, and g of x equals the cosine of 2x minus pi. So note a couple of things here. Note that we have, and maybe I'll give myself a little bit of division here. Why don't we go like this? So for part B again, notice that we could say that our a value for f equals our a value for g. We have like a 1 and a 1. We can see our trig functions also match, which is good, as they did match in this previous case as well. And then what we want to start looking at is our b values here. We'll see that our b values don't match, so we know that this will again be an out of phase set of waves. So here again we can answer no. And that is, notice, despite the fact that if we looked at the difference of these phase shifts, we would have some difference equal to an increment of 2 pi. So notice that 3 pi minus pi equals 2 pi, which is an increment of 2 pi k. But this doesn't matter because, again, we need to have matching periods or matching frequencies or matching b values, the way we've defined it in a previous example, in order for these waves to be in phase. Now let's finally look at C, where we have f of x equals 3 sine x and g of x equals 2 sine x. So if we want to determine if these two waves are in phase, we would start and notice here immediately, hey, AF does not equal AG, therefore these waves are out of phase. So again, we can answer no to our question. And note that's still true despite the fact that, say, our k values for f equal our k value for g, so we have the same the same period or frequency for both of these waves. Note also that we look at these phase shifts. This is 0 minus 0 equals 0, which is a multiple of 2 pi. Again, we don't care because our amplitudes don't match. These waves are out of phase. So again, if we have in-phase waves, we should have matching amplitudes, we should have matching plus or minus signs for our a values, matching sine or cosine, and then when we look at matching k values, and finally the difference of our phases should be some multiple of 2 pi. And in all these cases we can see that's not true, or at least one of those conditions is not true. Therefore we answer no, none of these phases, or none of these waves are in phase.